Okay, day 21. And rough. Monkey math. Oh, not the monkeys. No, the monkeys are back. You're worried that they're going to try to steal your stuff again, but it seems like they're just holding their ground and making various monkey noises at you. Eventually, one of the elephants realizes you don't speak monkey and comes over to interpret. Okay. As it turns out, they overheard you talking about trying to find the grove. They can show you a shortcut if you answer their riddle. Each monkey is given a job, either to yell a specific number or to yell the result of a math operation. All of their number yelling monkeys know their number from the start. However, the math operation monkeys need to wait for two other monkeys to yell a number, and those two other monkeys might also be waiting on other monkeys. Your job is to work out the number the monkey named Root will yell before the monkeys figure it out themselves. How is that a riddle? For example, root, PPPW plus SJM. So PPPW, I'm guessing, is this guy, and he's waiting on this guy and this guy. Okay. Each line contains the name of a monkey, a colon, and then the job of that monkey. A lone number means that monkey's job is simply to yell that number. A job like AABB means the monkey waits for monkeys AAA and BBB to yell each of their numbers. Then that monkey yells the sum of those two numbers. So in the above example, monkey Dursum has to wait for monkeys. Okay, the process continues until Root yells a number 152. However, your actual situation involves considerably more monkeys, of course. What number will the monkey named Root yell? Okay. And then let's grab our test input. That's not that many monkeys. That's not that many monkeys at all. Okay. Yeah, sorry. All right, so 1,677 monkeys. Great, no problem. So the first thing we need to do, of course, is bring in our data, as always. So we're going to just make a monkey class. Okay. So then this is going to be immutable list of monkey. And then for line and input. All right. And then we need to do monkeys.add. This is immutable. Okay. Add monkey. Monkey 1, monkey 2. Oh, I forgot to get the character. Okay. Operation and then output. And then this should be easy enough. While monkeys.find it dot monkey 1, monkey 2. Oh, I never put name in here. Okay. Okay, so name, monkey 1, monkey 2, operation output. While its name is not equal to root, dot output is equal to long dot max value. So basically, while the root has not put out a value yet, then we're going to iterate through all the monkeys. Okay, so that's their outputs. If monkey 1 out is equal to long dot max value, and monkey 2 is not equal to long dot max value, so monkey dot, we're going to just do this as a when. Output is equal to when operation, monkey dot operation is, and then we have to worry about plus, minus, times, and divide. And else throw an exception, because otherwise I can't use this as an assignment operator. Okay. And then, is that it? I think that's it. So at which point we only care about returning this. So return monkeys.findRoot.output. And let's see if it runs. Check failed. Oh my gosh, okay. All right. I probably should have left this min. That's fine. That's more correct. Anyway. All right, let's try that again. All right. And then let's try this. That's the right answer. Okay. Part 2. Due to some kind of monkey-elephant-human mistranslation, I don't know how that could happen, you seem to have misunderstood a few key details about the riddle. First, you got the wrong job for the monkey named Root. Specifically, you got the wrong math operation. The correct operation for monkey Root should be equals, which means that it still listens for two numbers from the same two monkeys as before, but now checks that the two numbers match. Got the wrong monkey for the job starting with human. If it isn't a monkey, it's you. Actually, you got the job wrong too. You need to figure out what number do you need to yell so that Root's equality check passes. The number that appears after human in your input is now irrelevant. In the above example, the number you need to yell to pass Root's equality test is 301. This causes Root to get the same number, 150, from both of its monkeys. What number do you yell to pass Root's equality tests? Okay, so for part 2, we're going to keep things pretty much exactly the same for the first part. So all of our inputs exactly the same, except for human, we're going to override it to not have a value. And then I'm also going to give it a monkey 1 and a monkey 2 back to itself. This is just to prevent a null pointer exception and allow me to use the same code I already have. Other than that, basically, it's just going to not update. And then I got to change the roots operation from, I think it was a plus or whatever, to an equals. And then everything else is exactly the same. The loop is, instead of waiting for the root to have a value, we're going to wait until there's no changes. So basically, we're going to say, there's no change, and then we're going to run through all the monkeys. If there's a change, then we run through the whole loop again, and we do that over and over until we don't have a change. If we hit the human's going to rely on human, and then neither of those are ever going to have something to update because the output is still min value. So no big deal there. The only other difference is, again, just kind of the end condition. I had left it as waiting for the root to update, but the problem is that it doesn't update everything under there, so eventually it runs into a place where it has two values that it doesn't know. So I had to change the end condition to be the changes instead of root. No. But other than that, all exactly the same. And then I need to change the root's output because it doesn't have an output yet to basically just be the max of either one of its children. And then I'm going to basically do the whole thing in reverse, and the easiest way for me to do that was I just do recurse monkeys. So it's pretty much the same thing, but in a recursion state instead, and going from top down. So it's going to take a list of monkeys, it's going to find the current one and the target. The target is the current one's output. If it's a human, that's the end condition, just return target all the way up the stack. If it's not a human, then basically we find that current monkey, we find its two children, and whichever of the children it does not know is going to be the one that we update. So if that's the first one, this is pretty simple. It's just going to be, basically the target opposite of whatever the original operand was. And if it's the second one, the output's a little bit different. Hang on, let me. So. Basically, if this is our table, so basically it's some sample data. So if our first monkey is an 8, our second monkey is a 2, plus basically we need to do the target minus the second one, and then if it's a minus, we need the target plus the second one, and so on. The second monkey is a little bit different because the minus and the divide flip the order. Like the add and multiplier are commutative, so it doesn't really matter, but we basically need to make sure we get the orders right for several of these as well. So I just put that out in a little thing to make sure I got the math right, and basically put those in there. And then whichever one it is, the next thing we want to do is change its target and then recurse down to the next level. So that's just going to start from the root, go to whichever one it doesn't know. We're just going to go whichever one it doesn't know. We're just going to go whichever one it doesn't know. The other thing I was worried about originally was I don't know if there is any place where there would be a value that's used twice. So like a single monkey that's screaming that two other monkeys are listening for. So I did a quick little bit of code just to do the counts for how many times everyone's listed. And if any of them were listed more than once, then, let me know. And the only one listed more than once was the human that I added in to be, used twice. So that made it a lot easier. You can simplify it quite a bit that way. Anyway, so once that recursion runs through, that's it. You just return that value, and that's all there is. If you have any questions, of course, hit the comments. I will always have the updated code in the GitHub below. And other than that, I will see you tomorrow.